Greetings to all. I'm Suba, working as an assistant professor in the Department of ECE, SASTRA University, Kumbakonam, and my research supervisor is Dr. Sosam, Professor, Department of ECE, SASTRA University, Tanjavur. My research topic is modeling and analysis of cyclostationary spectrum sensing with dynamic thresholding using artificial neural network and machine learning. The main objective of my research is to develop a model and analyze the cyclostationary spectrum sensing system by predicting the primary uses under varying signal-to-noise ratio conditions. First, to predict the threshold value for the probability of reduction by analyzing the number of samples. Next is modeling of cyclostationary spectrum sensing system with MPSK modulation and also with MQA modulation with using artificial neural network. Finally, modeling of cyclostationary spectrum sensing system using machine learning techniques. Cognitive radio plays an important role in identifying the primary user, that is, by predicting the empty space. It can utilize the empty space. Whenever the primary user enter into the second user or the cognitive user leaves space for that primary user. So it utilizes the spectrum without interfering the primary user. So the main objective of my research is can be obtained by taking artificial neural network with a different signal to noise ratio condition, different modulation like MPSK and MQM are involved, and different channels like AWGN, Raleigh, and Gaussian are used to predict the number of samples by predicting the dynamic threshold value under varying signal to noise ratio conditions. The MPSK and the MQA modulation are involved. By comparing these two modulation, MQAM provide better accuracy when compared with MPSK. About 90% of probability of reduction can be achieved with the help of MQAM. The second is about machine learning technique. Machine learning technique, we can use pre-trained CNNs like AlexNet, DenseNet, GoogleNet, ResNet for probability of reduction. Here also MPSK and the MQA modulation are involved with different channels like Raleigh, Gaussian, and AWGN. So, two models are involved to find the probability of reduction. When compared with ANN, machine learning techniques provide better accuracy. So, the investigated cyclostationary spectrum sensing for primary user prediction can be done with the help of machine learning technique. So, pre-trained ML models are involved to estimate the threshold value. Overall, the conclusion of the research is investigated the cyclostationary spectrum sensing method for the prediction of primary user. So develop a system model for the estimation of threshold value. Artificial neural network and the machine learning models are involved for two different modulation like MPSK and MQM, and with different channels like Raleigh, Gaussian, and AWGN. Among these two models, machine learning techniques provide an improved accuracy in the probability of reduction. Finally, I thank my research supervisor and SASTRA University to carry out my research successfully. Thank you.